Are aliens out there, or are they just in our heads and headlines? From UFO videos to exoplanet atmospheres, the evidence ranges from wow to weak. Here's how scientists actually judge claims, where the data really points, and what it would take to prove life beyond Earth. Welcome to What You Might Not Know. 25 facts that turn alien hype into a science-based checklist. This question reshapes our place in the universe. The term aliens simply means life beyond Earth, anything from microbes under Martian ice to starfaring civilizations. Why it matters: even fossil microbes elsewhere would prove life is not unique to Earth. That single discovery would redefine biology, religion, philosophy, and policy. According to NASA, finding life is a core goal across missions because it would rewrite how we think about origins and destiny in the cosmos. The Fermi paradox frames the tension. The universe is vast and old, so where is everybody? With hundreds of billions of stars in our galaxy and potentially trillions of planets, simple probability hints life could be common. Yet we have no confirmed contact. The paradox pushes us to ask whether we're looking in the wrong places, with the wrong tools, or making human-centered assumptions. The Drake equation isn't a prediction, it's a conversation starter. Each term, habitable planets, life arising, intelligent life, communicative civilizations, has giant uncertainties. According to the SETI Institute, the equation's value is in guiding research, not promising numbers. Better telescopes, longer surveys, and improved chemistry models gradually turn guesses into measurements. Extraordinary claims require extraordinary evidence. In practice, that means independent sensors, raw data access, instrument calibration, and reproducibility. A blurry video is an anecdote, not a dataset. Peer review, open methods, and error bars aren't bureaucracy. They're how science prevents fooling ourselves. Misinformation thrives where curiosity outruns evidence. False alien claims can drain resources from real research and erode public trust. A clear checklist, what was measured, how, by whom, with what uncertainties, lets anyone evaluate sensational headlines without becoming cynical. Skepticism is not denial. It is disciplined curiosity. Aliens matter because the answer reshapes science and society, so the evidence standard must be high. To judge claims today, we need to know how our search began. Humanity has imagined neighbors for millennia. Ancient and early modern thinkers speculated about many worlds, but speculation became science only, with telescopes and physics. As astronomy matured, the question shifted from philosophy to measurement. What can we detect, and with what certainty? The Mars Canals myth shows how wishes distort data. In the late 1800s, observers saw linear features and imagined engineering. Better imaging erased the lines. Later flybys and landers revealed a real Mars, dry, cold, fascinating, but no canal-building civilization. Lesson: higher resolution and better instruments often turn marvels into mundane geology. Modern SETI began in 1960 when Frank Drake aimed a radio telescope at nearby stars hunting narrowband signals unlikely to be natural. According to SETI historians, this launched systematic technosignature searches, radio, laser flashes, and now waste heat surveys. A null result so far doesn't mean absence. It means keep improving the search. The 1977 WOW signal remains intriguing because of its narrowband strength and lack of a repeat, but with no follow-up detection, it fails the replication test. It's a reminder that single events, however striking, don't satisfy modern standards for discovery. Government interest has waxed and waned. Programs have cataloged reports, improved sensor practices, and urged better data. Independent scientific panels in recent years emphasize transparency, calibration, and multi-sensor evidence. According to public briefings, none have verified extraterrestrial technology. History shows how easily we can misread the sky, and how better tools correct us. So how do scientists actually separate signal from noise? The method is the message, data over drama. A rigorous claim starts with raw data, not clips. Scientists demand timestamps, sensor specs, locations, and error budgets. They model the instrument first: optics, exposure, bokeh, rolling shutter, parallax, and atmospheric effects. According to basic metrology, if you don't understand your sensor, you can't understand your signal. Life detection targets chemistry out of balance. Co-presence of gases like oxygen and methane suggests active replenishment. Aerosols, haze, and isotopes add context. According to recent Nature and Science reports, atmosphere spectra from exoplanets are noisy, model-dependent, and require multiple lines of evidence before whisper becomes claim. Technosignatures widen the net. Narrowband radio, short laser pulses, city light glows, or mid-infrared waste heat from industry or megastructures. The famous dimming of KIC 8462852 sparked megastructure headlines. Dust proved a better fit. The rule holds: prefer the simplest natural explanation that matches all the data. Many flashy UAP videos resolve into known phenomena: Starlink satellite trains, Venus near the horizon, aircraft viewed head-on, sensor glare, insects near the lens, or planes time aliased by shutter speeds. Multi-sensor corroboration, radar, IR, optical, and eyewitnesses with synchronized metadata dramatically raises confidence. Citizen science matters. Open source tools can extract frames, stabilize footage, and overlay star maps to test trajectories. Triangulation from independent vantage points, plus weather and satellite databases, often cracks mysteries. The checklist mindset isn't gatekeeping. It's how outsiders contribute real solutions. Reliable alien claims look like lab work: traceable, testable, and repeatable. Where does the evidence stand right now? The sky is busy and proof remains elusive. Thousands of confirmed exoplanets include rocky worlds in temperate zones. According to NASA mission archives, spectra of a few atmospheres show intriguing chemistry, yet none meet the multi-line, multi-instrument threshold for life. The signal-to-noise frontier is where patience pays off. Mars keeps teasing us. Seasonal methane hints, ancient lake beds, and organics in rocks all excite astrobiologists. But methane sources can be geological, and organics can be abiotic. Without clear isotopic fingerprints or modern microbes, the red planet remains a maybe. Interstellar visitors like Oumuamua and 2I Borisov proved objects drift between stars. Oumuamua's odd acceleration and shape sparked speculation, yet natural explanations, outgassing of unfamiliar ices or dust-driven effects, fit the data without aliens. The moral: strange isn't the same as sentient. Recent scientific reviews of UAP emphasize better data pipelines. Panels have urged calibrated sensors, standardized reporting, and open analysis, while noting no verified extraterrestrial technology to date. The path forward is instrumentation, not anecdotes. Earth's extremophiles rewrite the possible. Microbes thrive in boiling vents, acid pools, brines, and deep rock. According to microbiology surveys, life exploits niches wherever energy gradients exist. That expands where we look, but it doesn't grant automatic confirmation elsewhere. We're surrounded by promising clues, but confirmation needs tighter data and cross-checks. So what happens if we finally catch a real signal? Proof will look boring until it changes everything. Expect a slow, careful rollout. A credible biosignature would appear across instruments and epochs, with teams trying to break their own claim. Expect preprints, rebuttals, and follow-up campaigns before anyone says discovered. Missions sharpen the search. Ocean world probes, long baseline telescopes, and improved spectrographs for faint atmospheric lines. Europa's subsurface ocean, Enceladus plumes, and Titan's chemistry are prime laboratories for habitability. If a biosignature holds, Phase 2 asks origin and ecology. What metabolism? How abundant? Does it alter climate? According to astrobiology frameworks, the bar for life is co-evidence: molecules, context, and plausible chemistry that hangs together. A technosignature would trigger a global verification protocol. Independent observatories, raw data releases, and targeted follow-ups. The first announcement would likely be cautious, candidate signal, while the world checks for satellites, reflections, and terrestrial interference. Contact is not required for consequence. Knowing life exists elsewhere reshapes ethics, environmental priorities, and our long-term survival plans. METI, messaging extraterrestrial intelligence, will remain debated. Some argue silence is safer, others say curiosity is our calling card. Strong claims will survive stress tests. That's how a whisper becomes a world-changing fact. Let's land this with a clear takeaway. The alien question deserves wonder and discipline. Use the checklist. Who captured the data? What instruments and settings? Where is the raw file and metadata? What alternate explanations were tested? Was the result reproduced independently? This mindset doesn't kill excitement, it protects it. The cosmos is big enough for surprises, and science is built to recognize them. Whether the first proof is a microbial metabolism under ice or a narrowband ping from a nearby star, the same rule applies. Extraordinary evidence, openly tested, will stand. Until then, be curious, be kind to uncertainty, and ask for the data. The first aliens we find may be microbes, yet they'll upend everything. Audiences crave civilizations, but biology begins small. A robust microbial biosignature, chemical imbalances sustained over time, would prove life starts wherever conditions allow. That's the radical part. If it happened twice nearby, it probably happens often. Civilizations could follow, but the headline shift arrives the day slime becomes signal. Wonder doesn't need saucers, it needs evidence. Science is full of surprises, stay curious. Don't forget to like, subscribe, and share as we learn more together.